chloride is smaller than iodide, right? So if you pick up two big iron, you make a bond, the distance between sodium and iodide will be much larger than the distance from sodium and chloride, right? And when the distance is larger, the energy will be smaller. Okay? Is it clear? Yes? Okay or not? Yes? How about the calcium and oxygen? So if you pick up sodium and calcium, calcium will have two positive charge and sodium will have only one. Oxygen you have two negative charge, chloride have only one. So for sure, if you have the same distance, the energy of calcium or oxygen will be 4 times larger than the energy between sodium and chloride, right? Because 2 times 2 equal to 4. So experimentally, you will see that sodium chloride's lapping energy is 910 kJ per mole. Cesium iodide is only 600 kJ, smaller than that. And calcium oxide is 3,400, almost 6 times higher than sodium chloride. So you see how the charge impact on the lactic energy. Okay? Is it clear? Okay. So now you have a Born-Haber cycle to calculate the lactic energy. By definition, the energy, lactic energy, is the energy required to break sodium chloride solid to make sodium cation gas and gaseous chloride anion. Okay, so you need to calculate this one. How can you calculate this one? You need to know about the energy you put inside sodium chloride to break this sodium chloride to make sodium solid and chloride gas, because they are at the normal physical state. Okay? Neutral charge. And then you need to put energy to evaporate into one sodium from solid to become sodium gas. And then you need to put also energy equal to the bonding energy of the chloride to break the chloride-chloride bond. So you have the sodium gas and chloride atom gas. And then you need to put ionization energy to remove one electron from sodium. So you have sodium cation gas, free electron, and chloride gas. Then the electron will move to the chloride, so you have electron affinity, right? So when the electron moves here, you have sodium gas and chloride gas. So if you know this value, this one, this one, and this one, you could be able to calculate this one easily. The reason is following. If you start from this potential, this point, you go anyway, and when you be back to the same position, the net energy you generate during the cycle will be 0. Is it correct? You start from here, you go wherever you want. When you be back, you start exactly at the same potential. So the net energy you generate will be 0. So that means you put this one plus it, plus it, plus it, plus it one, and plus it one, it will be equal to 0. So you know 1, 2, 3, 4, 5 value, you could be able to calculate this one. It's very easy mathematics, right? Anyone can make it. But please practice this one during the tutorial. You need to calculate to make its calculation correct. That's all. Now, we move to the covalent bond. In the covalent bond, the atoms tend to share the electron until they are surrounded by 8 valent electrons. For example, you have hydrogen with 1 electron. Another hydrogen also have 1 electron. So the 2 electrons decide to share. So each of them will have 2 electrons. Okay? So in this case, the two electrons will be shared equally between the two atoms. The same for chlorides. The chlorides will have 7 electrons. The second one also have 7 electrons. If they decide to bring this electron and this electron to share, then they will have 2 electrons shared by 2 atoms. So in that case, this atom can say that, okay, I have 8 electrons, and this atom also have 8 electrons. So they both can satisfy the octet rule. The concept is following. I try to explain very simple the way you understand the covalent bond and the ionic bond. Okay? You guys, after 3 years study at USDF, you decide to create a startup company, right? And you want to do business, I don't know in which field, but you need about $2 million US. Okay? $2 million US to start. You have already $1 million US. Now you have 2 possibilities. One, you come back home to ask your parents, saying that, okay, now I want to start my business. I need 2 million. I have already 1. Can you give me 1? Okay. Your parents say, okay, why not? So they will make a bank transfer to your bank account 1 million. So they give you 1 million. You receive 1 million. So you satisfy 2 million you require to start the startup company. Okay. And your parent will lose 1 million. The interaction between you and your parent become ionic interaction, very strong, because you borrow money from them. Okay? And in the company, you can decide alone. But each day you come back home, your parent can control you back. Right? Okay? The bonding is extremely strong. Because only strong bonding like that can give you electron, can give you $1 million US. Okay? So that is ionic bonding. And the energy to break this bonding is extremely high. Okay? To break it, you need to return $1 million US first. And then say thank to your parents because they trust you. And thus have no price. So the energy to have this to break this kind of ionic bond is extremely expensive. So that represents by the lactic energy. Okay? The second way is that you don't want to borrow money from your parent. Okay? Or your parents say that, or you are joking. I don't believe in your business. Okay? So the second possibility is that you come to ask your classmate. He have also 1 million US. Of course, he will not transfer to you 1 million because he or she will not borrow you this kind of money, right? But you guys can discuss to say that, okay, I bring 1 million, you bring 1 million, we share the 2 million and we start our shared business. Okay? So your friends can say that, okay, 2 million belong to the company, so belong to me. You can say also that the 2 million belong to the company, so belong to me. So both of you, actually before sharing, both of you have only 1 million. But because you put in the same company, you share the ownership. So you say that the 2 million belong to you because the company belong to you. Okay? So both of you will have the same ownership to this company, and all the discussion will be made by both of you. Okay? So that bonding is actually covalent bonding. And this covalent bonding can be break easily. Okay? The day your friend will not happy, he will be back. He say that, okay, I stop the business, I take back 1 million, the company stop. The bonding stop. Okay? So you see that the concept of sharing electron is exactly the co-ownership in the company startup like this. Okay? And you can imagine already in terms of bonding energy, the covalent bond is much weaker compared with ionic bond. Okay? Is it clear? If you guys, you try to invert the situation, you try to make your friend become ionic and your parent become covalent, you will fail in your life. Because you try to gain again the nature. Okay? So the parent bonding is ionic bonding. Relationship with friend will be covalent bond. Don't try to invert it. Okay? Including with your husband or wife. Okay. So why we need a covalent bond? Because the two nuclei are both positive charged. So they try to expel each other to get as far as they can, because they try to low down the potential energy, right? So if you want to keep them in a good distance to make a bonding, you need to share something which is a negative charge. So you put electron in between, the electron will attract this nucleus, so the two shared electrons will keep the two nuclei in a good distance. So in the co-ownership company, money bond you guys. When you have no more money, the relationship will break, for sure. Right? Okay. Now we talk about different types of covalent bond. So, if you share only 2 electrons, only 2 million, then you have a single bond. And in that case, we call the bond order equal to 1. Bond order equal to 1. If you share not 2 electrons but 4 electrons in between 2 atoms, so 2 electrons equal to 1 bond, so 4 electrons equal to 2 bonds. So in that case, we call the double bond, and the bond order equal to 2. So you take the number of electrons, you divide by 2, so you have the bond order. And you can have the system where 2 nitrogen atoms share not 2, not 4, but 6 electrons. So the bond order is 3, and you have a triple bond. Okay? So, the question, is it possible to have a bond order 0.5 or 1.5? No? Why? The 2 can share 1 electron, right? If 2 atoms can share 1 electron, then you have a bond order 0.5, right? Is it correct? Because bond order is equal to the number of shared electrons divided by 2. When you share 2 electrons, you have 2 divided by 2, bond order equal to 1. If you have 4 electrons shared between 2 atoms, you divide by 2, so bond order will become 2. So, if you want to raise bond order 0.5, that means the system share only 1 electron. 2 atoms but share only 1 electron. Is it possible? Yes? How can it be possible? 2 atoms share 1 electron. How it can be possible? Imagine. Back to the company you just found. 2 guys, one put $1 million, the second one put $1 million, right? So the company have $2 million. Okay? You run the business. 6 months later, $1 million wrong. Okay? You make a wrong decision, the business will not run very well. You lost $1 million. So the company now remain only $1 million. Okay? And this $1 million still divide by 2 because it belongs to both you guys, because it belongs to the company. So in that case, you will have bond order 0.5. But you can imagine that when you lost $1 million like that, the bond between you and your friend will be weaker. Okay? You will have a more time to fight each other. The discussion becomes harder. If you remove the second electron you share, that means you have no more electron share, the company stop. The bond between you guys will stop. Okay? So the bond order means there's no bond. That bond order, sorry, zero bond order means there's no bond. Okay? So it means what I want to say here. Bond order 0.5, 1.5, whatever is possible, depends on how many electrons you share. Okay? If you share one electron, the bond order will be 0.5. If you share two electrons, bond order will be 1. But the most interesting thing I want to bring to you to have a coefficient to think about that is that if you want to break a bond, a single bond, that means two atoms have two electrons in between. The company have 2 million electrons. You want to break this company. You cannot remove both at a time. That means you cannot remove 2 million in one time. It will be very hard. Because they start the company, if you want to remove 2 million, they will fight against you. Okay? But if you are smart enough, you take first 1 million. Okay? The bond order becomes 0.5. Okay? The distance between two guys becomes longer. The bond between them becomes weaker. And the second million, it will take easier. You get what I mean? So if you want to break a chemical bond, the first electron you remove will be extremely difficult because you need to pay more energy. But when you remove the first electron already, the second electron becomes very easy. Okay? Because the two atoms get very far from each other already. They tend to say bye-bye already. So you come to break the second electron, it will be easy. Okay? So if you want to break a single bond, first oxidize, that means take one electron. And then second you come to take a second electron, it's much easier. If you want to break a double bond, you need to pay first one electron, one energy to remove one electron. So we have bond order 1.5. The two atoms get longer. You remove second one, so the bond order becomes 1. So they get longer, start from the double bond, become single bond already. And then you remove the third one, it will almost break. And the fourth one will be the end of story. Okay? Khi mà hai thằng Trọng vừa bắt đầu thành lập công ty, đừng có đến mà lấy hết cả của nó đánh chết. Đúng không? Khó lấy lắm. Nhưng mà hãy lấy một nửa tiền của công ty đi trước. Thì hai thằng nó bắt đầu fighting với nhau rồi, đúng không? Chỉ đến đặt một câu hỏi tiếp theo sẽ vứt nốt cái triệu kia còn lại. Okay? So in terms of bond strength and bond length, you will see that the single bond will be weaker than the double bond and weaker than the triple bond. And in terms of distance between the two nuclei, the triple bond will be shorter than the double bond and the single bond. You will see that the single bond, if you want to break this one, you need to pay 163 kilojoules per mole. But if you want to break the triple bond, you need to pay almost 7 times more energy, not only 3 times. You get what I mean? So it's not triple bond equal to 3 times of single bond. It's much more than that. And because of this, you know, the molecule of nitrogen is extremely stable, right? It's very stable. It's have almost 78% in our air. So when you learn at high school, you learn about very important chemical reaction in the industry, chemical industry. N2 plus A2 equal Na3, right? You take nitrogen, you make reaction with hydrogen, you have Na3. And this Na3 will decide all the agriculture over the world. Because without Na3, you cannot plant any tree. Okay? So all the food production will stop if you don't have Na3. And we know that this reaction is extremely difficult because the triple bond of nitrogen. So you need to bake at high temperature, almost 500 degrees Celsius. You need to bake high pressure and use catalyst. However, in the nature, there's one enzyme called nitrogenase. It can fix nitrogen at the room temperature and atmospheric pressure. So you don't need high temperature to fix Na2 and Na3 in the nature. So I used to say, to tell to my students that the best chemistry student is in the nature. So if you want any chemical process, try to learn from the natural process. Okay? Or in other words, we can say that the future belongs to biology. Okay, we try to practice a little bit. Arrange the following compound in order, increasing halogen bond. A, B, C, or E, please. Very easy. A, B, C, or D.
Có cái công nghệ gì với một con laptop của 10 triệu. Tại vì ta vô là có cái nào tốt hơn không? Tại vì máy hơi tâm thì khi còn có thể nói phần dưới 20 triệu. Chiều nay tao presentation. Đọc chưa thôi đọc chapter. Đấy là chapter đi.
We solve this question and then we end our class.
Hôm nay thầy học sinh rồi thầy đi quay
Any idea?
tao rồi thầy sinh rồi thầy đưa luôn vào TikTok
A, B, C, or D?
Facebook đưa luôn mỗi thằng làm quiz.
A. The correct answer should be B.
B.
Because when you go from top to the bottom, the atomic radius will increase. Okay? So when the atom becomes bigger, the distance from the two atoms will become longer. Two nuclei become longer, right? Is it correct? So the fluoride will be the smallest one, so the distance will be shorter, and then by following by fluoride, bromide, and iodine. Last question. If you want to break the chemical bond belong to the halogen compound, which compound will be easiest to break the bond. Iodide, right? Because the distance between the two nuclei is very far. So they will become easier to cut it. Okay? So in terms of bond energy, iodide will be weakened. Okay? So I think that we will end our lecture this morning today here. We will continue in the next week, the week after, because next week we have the midterm examination. Okay? Any question? No? Thank you. Good luck.
Speed run node.